Welcome to our Vector Forum 24. Today, second session, and I'm very glad that we have here the presentation from Bosch. And I welcome very much Michael Rölleke and Ljubomir Jovanov. My name is Christoph Ebert. I'm Managing Director at Vector Consulting Services. I will moderate this meeting and also give a short introduction to prepare for this 1 hour presentation. We will definitely stay in the hour, and I will in a moment give you also details on how this whole setup will look like. So thanks for joining. For those of you who listen to recorded version, there's of course no interaction directly possible, but we also have at the end of this presentation some link where you can further contact us. I'm now going to share presentation to start, and our topic for the whole Vector Forum is deploying emerging technologies. Today, a very key emerging technology. We talk about development of an AI system, and of course, everybody might say, well, AI, everything has been said, has been done, but the truth is there's a lot of hype. But if you look to real systems with AI, there's not that much. And so I'm very glad that we have with Michael Rölleke and Ljubomir Jovanov two persons who really know what they talk about and have a very practical use case from Bosch on sensor development. I will very briefly outline the setup, and then we have this presentation, and then I will summarize afterwards with some concluding remarks. And just for those who are not that much in connection with Vector, Vector is a global company with almost 4,500 people, and we work in different domains. Industry domain, major domain is automotive, but we also work in related critical systems such as medical or transport or aviation. And you see on the right part the major products of Vector, which is activities in product lifecycle management, application lifecycle management, embedded software, where we are market leader with our AUTOSAR stack, testing equipment for all sort of tests, from the static analysis and unit test, that means verification, up to all sort of integration, network integration, system test, pen test, fuzzing, etc. We also work in diagnostics, calibration, which means to adjust systems for a specific environment. And as I mentioned, we also have services, which is my responsibility. The Vector Forum itself serves to connect your needs with our solutions. And our solutions can be grouped into 4 sectors, namely trust, technology, transformation, training. Trust, that is mainly safety, security, technology, all sort of technology introduction, like our today topic, artificial intelligence. Transformation, to prepare companies for change, because many changes are like straw fires, which look nice during the hype and afterwards fall down immediately. And we also offer trainings. And going backwards for almost 20 years of Vector Forum, you see that we have covered these areas almost evenly. And so this year we have a technology topic, but when we talk about deploying, what it actually means is that we not only have a technology, but we also have to make sure that the technology is sustainably introduced. So this is always a transformation topic, and it relates also to some degree into trust. If you think about cybersecurity, that is always a very critical domain, or in today topic with sensors. We also have functional safety impact, and we provide also the trainings on that. This Vector Forum is 1 hour. We have this spread over several weeks. It's always on a Wednesday for 1 hour. Within the hour, 10 minutes intro. This is where we currently are. Then there will be a presentation of about 20 to 30 minutes. Then we have the Q&A and some closing remarks in the end. Some technical guidance: if you have your MS Teams as an app, this could create instability. Our recommendation would be use the app really with the MS Teams, not go via the browser. And in case of problems, which it's always good to prepare, because then it will not happen. As experience shows, we will switch into WebEx. In that case, just have a look to your email. We will send an email as to all registered persons, and then we can hopefully, without much interrupt, continue in a different channel. This Vector Forum is for all of you who are there in presence. Again, not for those who listen to the recorded webinar, but for those who are today here in presence, you can directly interact with the speakers. If you go to your chat box in Teams, you can directly put questions. And with the questions, you can also like other questions. And then we will, in the Q&A part, look to these questions which have been sent during the presentation. And I will filter typically according to an amount of likes, but I might also group related topics to make the flow a little bit easier to follow. Finally, we have a quiz, which we will again also introduce at the end of this webinar. And this quiz is a kind of challenge where you can also win a prize, training, books, etc. So it's worth participating. And we will inform the winners in June after the completion of these different Vector Forum webinars. A few general comment, which is always important to have, be aware where is your emergency exit, independent where you are. You will get a PDF. We are looking into being on time, and the chat is what I just explained. Keep yourself fresh. For some of you, it might be very late in Asia, very early in US, or after lunch in Europe. So if you want, it's really the worst time of the day for all of us. But I think that's also why we have selected, because that allows each of us to join from Asia to United States and Americas, and therefore can directly proceed with some content. And one content which I want to bring forward is from our annual industry survey, where we always ask what are short and what are midterm challenges. And the one thing which is really unique this year is that the lack of competence is seen as a biggest short-term challenge, and also ranging quite high for midterm challenge. What it means is, with insufficient competence, you run always in a vicious circle, because it slows down innovation. It means quality, risk, rework. The rework eats more effort that eats again from your limited competences, and that is a downward cycle. So we take this Vector Forum also specifically with a topic like deploying emerging technologies to really grow competence. And that is also why I'm quite glad that with Lubomir and Michael, we have two experts who will really show now hands-on about AI introduction. We also have some other topics coming. Previous week, we had the CTO of Marelli talking about software-defined vehicle. Next week, we will have the topic about how to connect an SBOM with software development. Then we will have autonomous driving. We will talk about architectures in the medical sector, because that's always a lot to learn if you cross-fertilize disciplines. And we will have a hands-on intro into SDV development with my colleague Matthias Straub. And finally, will be one session about safety, which is currently very fast evolving, again, also because of AI. Each Wednesday, 1 o'clock like today, and you can easily register at www.vector.com forum. That said, let's just get now a teaser for what we expect today. We would like to get more insight into how to develop AI systems, and therefore here a brief survey, which is we enforce specific guidelines for developing AI-driven products. What's behind? We try to find out who of you is already actively working on AI products, not just the company, but you as participants. And of this group, who has real guidelines at hand? Because often we see with our clients that a lot is ongoing with AI, using Gen AI and all that. But when it comes to how do I protect my IPR, etc., there's not much. And what I want to emphasize is a couple of benefits and risk Productivity is certainly always the one which we see immediately when talking about AI, which is clear, but it's also a threat with respect to validity, integrity, not having the context, and therefore make sure you have transparency, establish some quality control for the results of whatever you have, code generation or sensor fusion, etc. Another opportunity is automation, which helps us to be faster, which helps us also to be automated with different workflows. Again, think about validation and not just use an AI tool. Content generation, very big thing, not only in marketing, but also for engineering. For instance, code or any other topic, like you can generate requirements, you can generate specifications. We've been done a lot of work to generate, for instance, Tara for security. That's all possible, but again, make sure you have the right solution. Make sure that you don't just disseminate your own intellectual property to an open AI tool. And finally, be aware of cybersecurity, because the increasingly Gen AI platforms are misused to create code fragments in order to harm your own code, because we know from GitHub, etc., that an increasing amount of engineers is now using Gen AI to generate code. I do that also with my students in university, but we would never ever do that here in Vector, because it's not at all professional. It's fast, it looks nice, but you don't get what you want, and the risks are very high. So be sure you use on-premise solutions and don't use any cloud solution. That said, contact us if you have any further questions on an AI-driven development or AI products. And I'm now going to hand over to my colleagues who will present here, which is Michael Röllecke from Bosch and Lyubomir Jovanov. And I suggest you briefly introduce yourself, and the floor is yours. Thank you.
Great. Thank you, Christoph, for the introduction. And I think, Lyubomir, it's now your talk in the beginning for introduction. Hello, Lyubomir.
Sorry. Hello, everyone. I'm Lyubomir Jovanov. I'm working for IMEC Institute in Belgium, and my topics are sensor fusion and computer vision for smart infrastructure and autonomous vehicles.
Yeah, and my name is Michael Röllecke. I'm working around 30 years for Bosch in different positions, and now I'm responsible for innovation and for developing new sensor applications for inertial sensors. Yeah, and in the next 30 minutes, we will give you an overview about our work we did in a European funded project. It's called NextPerception. We closed this project last year. And here we have a lot of applications, and we are focusing on how we can implement AI solutions for having this human monitoring. This is our main content. And the talk of today is lessons learned from our development for AI for smart perception sensors. Yeah, and the perception is human monitoring. This must be this is a very important point, and we have different applications. So Lyubomir has other applications than I, but all together are working in this direction. And let me start with a short overview about our talk today. So we will give you a very short introduction about our project. You find this also on a web page, nextperception.eu. It's Horizon 2020 project, and this is more a pre-development activity in Europe. We will show you a little bit about smart sensors. Then we have our applications here, AI for smart sensors. We have something about fusion of visual things RGB and thermal signals, and also with radar. And we have also a real-time sensor signal handling. At the end, we will give you an overview about our lessons learned combined on one page. And we start this month a second project. It's called DistriMuSe. It's not available on the web, but maybe in 2 or 3 months we will have also a server here, and then you can have also access to this project. So let me start a little bit with NextPerception.eu. As I mentioned before, health and well-being, this is one of our topic, and human monitoring. So the human is in the middle, and we have 3 different use cases. We have this vitality monitoring, we have driver monitoring, and we have safety and comfort and intersection. And as I mentioned, the human is in the middle, and we try to identify what the human want and how the human is using this or working in this situation. Yeah, and here at the base we have the perception sensors. Then we need AI, but during the large element of our system, we have a distributed intelligence. So AI is not located at one place. So we have different places with AI. And what is the output? The output is here our behavior and physiological monitoring. And then we have this application, health, well-being, and automotive. To come to the next. Sorry, I'm a little bit my computer. Yeah. So where we are, you can see this here. We are 7 countries and more than 40 partners. And this is a very large project. And we get funding in a range of around 20 million euro. And here you see a lot of, I will not say well-known European industries and also scientific organizations. So we have a large range of partners here. And as I mentioned before, we do sensing. Then we do some pre-calculation of things. We want to create a so-called reference platform where you can easily implement your solution based on our experience. And at the end, and this is the most important thing in our project, we have different demonstrators, around 20, because we have so many applications and so many partners. And in all the applications, we have demonstrations and we show this. And then you can see how good AI works and what is the challenge for the next implementation, maybe in real products. Next page. Okay, but first I want to go a little bit to the basics, because for sensors it's important that you have an understanding why sensors are behaving like they behave. Yeah, we have different principles. This is well known. And what is typical for a sensor? We convert a physical phenomenon into an electrical signal. This is very, very easy. And it's also very easy that we describe this by different characteristics. Yeah, you know most of them: accuracy, errors, drift, and so on. It's not so important, but what's important is we have a static view. So sensor is not moving, not in action, and we have a dynamical view. Sensor is in action. He creates data typically by using his purpose. And what's also important here on the right side for a sensor is we will have typically a systematical error. It's called bias. And we have some random error. It's called precision. These are, for me, the main elements for a sensor. And here, this graph identifies this very, very good. We do not have to reduce the random error. We have also to reduce the systematical error. And this is, for my application, a very important point. So this is not so important. Also, Christoph mentioned calibration before. Calibration is also to check the behavior and then to bring this more in a linear or in a function that we easily can determine the comparison with standard or with the real physical signal. It's more for understanding this. And what is the typical approach of the sensor? You see this here on the right side. We have the transducer. Transducer transforms the physical into electrical signal, but, and this is most of the worst thing in a sensor, we have an impact by the environment. Environment can be everything. It can be the voltage, it can be temperature. This is the typical one, the temperature. It can humidity. There are a lot of things, vibration. And this have an add to an output. It's not clear in the beginning about this, this impact, but the sensor signals show at the end how it works. And to have a better understanding, we use models. And here are a very simple description. This is a so-called transfer function. This is a mathematical view to such a sensor. This is a temperature sensor. I use this example because this is very, very clear. So we have here a block diagram, and you can also model this in MATLAB, maybe, to have the same behavior in your computer and to work with such a system. Yeah, and what you have to do, you have to define the model, and then you have also to validate the model. And at the end, the model represents the real world behavior. Yeah, and the question is why we use AI, because we know most of the things of the sensor, but the model has some problems. The model will not describe 100% the reality. So we need, in my view, we need more. And how to get more? The idea is, if we can measure a lot of things of the model, and if we know how the model has to react, then it's better to use machine learning to train an AI system to represent what the system works and how the system reacts. So we can implement a model of the real system, of the sensor, in an AI system, and this allows us in future to compensate these negative effects. Yeah. So the idea is, if you know how the sensor has to react, look to the reaction and then compensate this by such a system. This is for my application very, very important. For Lubomir's application, we have this classification. This is not direct use here, but also important, because if the sensor do not measure the right thing, then the classification can't classify it. Yeah, so sensor topics are also important here. To give you a little bit link between our work and the history of deep learning, we have a focus here on the elements which are very important for our work. This is a perception. This is the base of the AI. You know this very well. Propagation. This is a very important point that the system is able to learn, and then based on this, different level of complex systems are created during the time. Here you see the time frame. So we use most of the convolutional networks, CNN. Yeah, you see this. This is around 25 years old. This is, I'm going to say, an old system, but compared to this time frame, this is very, very old. And these are the base elements, the convolution network, and then more complex elements are created. You can imagine this like the model will be created by smaller sub-elements. And the model is then the LSTM, long short-term memory. This is also developed in this range. And after having this low curve, we are now in this area. We have support by Google Nets. We have different visual very good elements, and here with AlphaZero we have also the elements which are now in all years, and that we will use now in this ChatGPT function. So these are the base here, only to give you an idea. And the red marked elements are the elements we use for our work. So now we came to our applications. First, we start with Lubomir applications. This was thermal video fusion in VRU detection. These are the humans on the street, and I go afterwards to this real time. So Lubomir, please.
And so one of the important parts of the project was safety of vulnerable road users, or VRU, at the intersections. And the idea was to increase the precision and accuracy of their detection in challenging weather and illumination conditions. For that, we have used a number of existing networks. One of them is VGG16. This network was used to extract features from RGB and thermal images. This network was introduced in 2015, and it was the best one in classification of 1000 classes with 93% precision. Another concept that we use in our development within the product was a residual network, and what is important there is that transfer function of the neural network is presented as a sum of residual part and direct skip connection. What is important with this type of networks is that it enables larger depth, and it solves better the problem of vanishing moments in the network, and it also offers faster learning. And the third concept that we have used in our algorithms is transformer net. This type of networks was first introduced for language translation. So basically, each word in one language is scored against the other words in the other language to which we want to translate, and then each of these activation scores are compared, and appropriate words are chosen. But this concept is then also extended to image processing and computer vision, where the idea is again to find the best correlation in one modality with the image patches in the other modality. And now I will switch to precisely what we have done in the project. So according to the statistics worldwide and also in European Union, a large percent of victims in traffic accidents are pedestrians, and that happens sometimes due to the low visibility, sometimes due to the lack of attention of the drivers. So the idea is to improve that safety by using computer vision algorithms. And computer vision algorithms so far most often use these color or RGB images to recognize pedestrians and warn the driver about their presence, but RGB images are not perfect in a sense that if we have insufficient illumination, like in the dark or in the morning, so vulnerable road users will often not be visible enough to be detected. Then sometimes we have the case that the camera is blinded by headlights of a car approaching to it, and then it makes detection impossible. And within this project, we wanted to make these detections much more robust in case of dark and in case of rain or fog. So we have used additional sensors like thermal cameras and radar and LiDAR to provide some ground truth for learning. And one of the most significant results that we had in this project was this architecture for fusion between RGB and thermal images. So in the first stage, we extract some saline features using this VGG network that I've mentioned in a previous slide. And what this feature extractor does is it tries to extract salient features, which means the regions where we suspected that there is something significant like pedestrian. And then we try to fuse the information using this cross-modality attention transformer. So normally in the fusion, this is done much simpler. So basically, all the data is brought together or dot product is applied. But in this case, we try to do something more and to try to to make the fusion work in such a way that these two images or two modalities act as a consultant to each other. So in this cross-modality attention transformer, if there is an evidence of a pedestrian in thermal image and there is a weak evidence of pedestrian in RGB image, these thermal images will try to give a hint to a feature extractor in RGB that there is a pedestrian, and then it will in feature detector will reconsider the decision of having detection in certain region. And then these additional data from the other modality will be concatenated to the features of the current RGB image or internal one. And then based on this improved data or improved features, we perform independent region proposal using these two networks. And the result of these region proposal networks are this bounding box for each of the modalities. And then to make a final decision, these bounding boxes are fed to multimodal fusion transformer, which makes a final decision about the position of the detected object and also about the class to which this region belongs. Why do we have to do this second step and to introduce another fusion transformer is because most often it's not possible to achieve perfect alignment of these two images and features because there is some kind of parallax. We cannot have both modalities in the same camera, but we use most often two separate devices like two cameras. So basically, this is like the internal this is like internal organization of the left part of the block diagram. So basically, based on RGB and thermal image, we extract some patches like 16 by 16 pixels. Then we produce feature vectors out of them. So instead of 2D matrices, we have 1D vector. Then to each of these vectors, we append the information about the position, and then we feed this information to this cross-modality attention transformer, which has multiple layers that help us decide where this correlation exists and to enhance the current features. And then finally, we get improved features that helps us to have a more reliable detection. Then how is this feature enrichment done within this algorithm? Traditionally, we have a number of queries that are, these are the features that we want to correlate with trained data. So typically dot product is used, and then we have queries and use dot product, and then we have kind of values or scores that each query gets, and then we generate the output. But if we use this traditional way, some of the data will be lost because this dot product will attenuate some of the significant features. And instead of that, in our proposed method, we perform like cross dot product. So we multiply these RGB queries, so unknown data with thermal features and vice versa. Then we obtain these products with RGB queries and thermal keys and vice versa. And then again, we combine this with RGB and thermal values, and we get more reliable outputs for the detection and improved features. So, so in the next slide, yeah, we show the results. So typically, when this cross attention transformer is not used, we will have this detection drawn in green are correct, but then we will miss some detections that are drawn in red. While when we use this attention transformer, we will correctly recognize these objects that were not recognized when we don't use this cross attention transformer. So to make these results clearer, we have to also see what happens with underlying features. So the idea here is like to have high activation around each pedestrian and low activation in all other regions. And when we don't use this cross attention transformer, we will get these high activations only around the feet of pedestrians, and we will also have some false positives in other regions which are not logical. While when we apply this mechanism, we will have high activations only where they should be high. So that's like around pedestrians, and that's why we have basically improved detections of different objects. So yeah.
Sorry, I propose to skip this because
yes.
We are running a little bit out of time. Sorry.
Okay.
So what lessons learned? So
lessons learned. Well, in this project we have tried both ways. One is like to reuse existing networks. So we have concluded that by cleverly combining existing networks, we can improve their results compared to the baseline original network. Then also because there is a large community that already uses these networks, we can deploy these networks much faster and debug them much faster than compared to the case when we self-develop these networks. And then also like there are known drawbacks and points where these networks can be improved, so we can focus on these two important questions. And then like what are the cons of using existing networks is that we cannot, by using something that already exists for different problem, we cannot entirely adapt to the problem that we want to solve. And also sometimes these existing networks will have suboptimal performance compared to the custom built network for the particular problem. Okay, that's, yeah.
Okay, thank you. Then we go a little bit to this real-time sensor. And what is here the topic, as I mentioned before, we have a sensor signal and we have signals from the environment, and these signals have an influence to the sensor signals. And this simple model show how it works. Yeah, you have the different transfer functions, you combine this, and the question is, can we learn this impact? Yeah. We work on a normal AI topic. So we look to the data, we look to the model, and then we try to implement this and how it looks like. So we have some data lines with sensor measurements. So we use a time frame. We extract features, we merge the features together, we use different methods, and at the end we combine this to one sample, because we have the focus on one signal line, and we want to calculate for this single line the failure. And all other lines are cross or environment information. And we feed everything together to judge here this failure. And how we do this, here are a little bit representations from Keras. Yeah, so we have here a convolution, like mentioned here. And here, yeah, different solutions are possible. You see it looks very similar, but we have different data flows through the models. Yeah, I will not go in detail to this. We have also the possibility to learn from the existing models and use this ResNet. Also, Lubomir has this inside of his application. And this comes to the end that we get an improvement here. We can here see this on this curve. This is not really good, not as good as I expect. We see that for driving scenarios, this is a real application of our sensor. This is an inertial sensor. He measures the movement during driving. We get an improvement by a factor 3 to 5, but this is not constant. And so this is a topic for the next level of project that we want to improve this. And what is my lessons learned here? So a network can learn this environment impact to the sensor. This works. And we are also using the existing work for AI. So we use the tools, we use the elements, and this is very, very helpful. But we have no validated serious production today, and the solution space is very, very large. Yeah, and in the open source area or in the classification area, we have some competition and campaigns to do so with some available data. And this is my proposal to go also this direction. And in discussing with the EU, this is also in Europe an idea that a lot of companies will produce data, and people are able to have access to this data and to help us to improve our models. Yeah, this is I do not want to go here. Yeah. And so we are at the end of our presentation, lessons learned from development AI for smart sensors. And thank you very much for your participation of our talk today. And yeah, it was a big honor to present this here in this forum and to give you the possibility to have a look to our work. If I summarize this a little bit, so our work is strongly supported by the available elements on the AI market, I will say. Yeah, so we had a lot of open source elements we can use. And but this is mainly for experts. If we come from the application point of view, maybe from the sensor development, it's very hard to go inside. Yeah, and if we can lower here the threshold, I think this is helpful for the whole industry. And at the end, we do not mention this here very, very strong, but data is the key. And without data, we are not able to train the models in real world behavior. And this is one of the important things of our work going to real world applications. Okay, so we are nearly in time. Christoph, it.
Thank you, Lubomir and Michael, for this quite good overview, giving us an introduction how practically using sensor fusion with AI, and also we got a brief tutorial on sensors, what kind of, let's say, effects they produce, how can you deal with all that, and some guidance on AI. And that brings me already to the questions, and I would just start here at the top because that one looks like a quite broad question, maybe from Sean Miller. What AI development guidance could you provide for the engineers? In other words, would there be like the three major topics where you say, this is where we suggest you pay attention, or this is where we suggest you get started? What were your major lessons learned?
If I like to answer here, my first thing is data. So you have to organize your data. You need a very good database with easy access and to also to import, I will not say tons of gigabytes of data, but you must be sure that the data is in the right position. Then you must be able to implement a lot of AI models very simple. Yeah, it's more writing some text, and then the AI model will be created automatically. And this is also an important point for me. And at the end, you have to compare the performance, and this is very tricky. Yeah. So from our sensor system, performance will not show by having a classification of an object. Performance is a long time signal. Yeah. So you have to think about how to judge the performance. This is my answer here. I'm not sure, Lubomir, if you have from classification point of view an important thing.
Well, from the classification point of view, I think it's important like to focus on the cases where the model fails and then to observe them and try to figure out why the model failed by observing features and why this fusion didn't succeed. So I think like by limiting ourselves on these critical cases, that like the precision can be improved significantly.
Maybe I just add a short follow-up question. When Michael, you mentioned data matters most, which I fully support. I mean, you have to get the right training data. We had been working on AI-based testing and same situation. So we also worked on synthetic data generators. Do you also use this kind of things, especially on the, let's say, verge from an ideal sensor into a real-world sensor?
It's in my mind. Today, I'm not using this, but this will be the next step. So if you have the measurement data, then you have to extend this a little bit, have artificial data, and also to tackle some of the sensor failures. Yeah, this will be the next level. And but here it's for me not really clear if this is a classification topic or if this is a real-time topic. Yeah, you can also have a look here on classification. Yeah, but this is a totally other, from my view, a totally other aspect. Yeah, but it's very important to have this. Yeah, and also for us, it was having safety systems on the market. Yeah, sensor failures are an extremely important point. Yeah, if you look to functional safety, yeah, you must be knowing this. Yeah, and but it's not really clear for me if the artificial signals can be modified in the range of having a real behavior. Yeah, you can have everything artificial. Yeah, but we have to focusing on the, I will not say on the probability how realize or how to say this in English. Oh, sorry, I missed the word. But if this is only artificial or is this a possibility? Yeah, and then we have also to judge how large this possibility is. Yeah, but in functional safety you have to do a lot of things. Yeah, and I think this is the only way.
And the 26.26.2 is quite full for exactly these hardware measures. Yeah. Let's jump to a complete different topic, which received a quote, also quite a heavy amount of feedback. That's from Anke Müller, and she asks, what productivity increase did you observe with using AI for development?
Sorry.
What productivity increase did you observe? So, I mean, obviously you do that not just to use AI, but you mentioned already that helps you to better align with the different sensors, that you have a faster learning curve, etc. So did you somehow measure or guess the improvement in productivity with that?
I try to do this, but I have no good measure. Yeah, because the main focus is to show the functionality in the first time. Yeah, it's pre-development. It's not the real development. Yeah, and so I do not have here a good answer. Sorry.
Yeah, and I can imagine in such a challenging technical environment, productivity is not the only success factor, because you could also argue that here is much more about how do I really integrate complex sensor behaviors, how do I detect failure patterns, corner cases, etc. And I mean, in the end, you can claim this is also about productivity, but it's at the same time also about quality.
Yeah, but and we have also to reduce the complexity of the system. Yeah, so we must to have here an easy. I will not say it's very complex, but it must be easy for us as human to understand on which level we are and where we can improve the system. Yeah, so I work with maybe 150, 200 systems in parallel, and to have here an overview which is the best one and which can be used for the next level. I would say this is also a very complex point. And if you go to this classification topic, to the history, you see that I will not say millions, but 10,000 of people are working on this. Yeah, and so this brings the technique in the position we are now. Yeah, we can identify easy a traffic sign in a picture. Yeah, this is a huge amount of work. Yeah, we do not see this now. Yeah, and this is, I mean, say a problem, but we can only improve our systems if we have a lot of trainings and a lot of testings here. Yeah.
We still have a few questions, so maybe we now make the answers a bit shorter. The same Anke Müller had another one, which is high ranking. It's about what risks do you see with your AI products, such as liability, how to mitigate such risks?
Yeah. Maybe Lubomir, what do you say with risk?
With risk? Well, I think that before deploying this product, for example, for recognition of pedestrians and cyclists, it has to go through extensive testing until it gets to the desired level of performance. And maybe one of the previous questions was about like using artificial data. So to get to this point of performance, we have to record a large amount of data for training, but the point of recording this data is like to get to data which is close to the happening of some accident, but these accidents are rare, quite rare, and it's difficult to get to these cases. So to help our system to reach the required performance, there are already initiatives to use like computer graphics in order to generate these critical cases. And that's also somehow connected to realistic situations which are included to these simulated environments, so that accidents happen with the same probability that they happen in the reality. So like to avoid risks, definitely our AI systems would need much more testing before being deployed into real product, to a car or some smart intersection.
And one last question that comes from Stefan Walder. He asks regarding AI versus functional safety, what kind of lesson learned could you share?
From sensor point of view, there's not a big difference. AI can help us to support functional safety, and also functional safety can help us to improve our AI system, because the thinking and also testing is very important. Yeah, so it helps by creating these artificial things, and we have to check if artificial has a realistic view, and then use the methodology and do some testing and do other things to be safe. Yeah, whatever safe is. Yeah, this is my personal view. I'm not sure if this goes in the right direction from the questionnaire, but yeah, this is my view.
I think it's a very good point which you make. If I repeat, that was a wonderful sentence. I mean, on one side you said that AI can help to achieve functional safety, and functional safety can help to make your AI systems better. I think that's a good way to phrase it, because I mean, this is now anyway not the time for a complete safety tutorial. But the before mentioned standards like the 26262 or the 25119, etc., they all have a lot of ingredients related to hardware, related to different stages of verification, etc., robustness. And I think you made a good point here to say this is a, let's call it cross-fertilization. So I want to thank you both, Lubomir and Michael, for this very insightful presentation, and also for being available for a quite intense Q&A now on some remaining topics. I'm sure there are more than remaining. So for those who have further questions, you can also contact us. And as I mentioned, you will also get the handout or some part of the handout afterwards. I come back now to the closing part here, and that is just to show what
Christoph?
have the guidelines.
Yeah, you were muted, Christoph, but now we can hear you again.
Yeah, so the result was about 60% no guidelines, 40 have guidelines. So there's still some room to grow for having also some guidance on the AI development. Where do we go from here? And so first of all, we will have further such webinars and also interactive webinar in our Vector Forum. Next week, we will have Festo, that's industry automation, a different perspective, but also very much working in the domain of increasingly using software for all sort of automation. And their topic will be demystifying the software bill of material. That is, for instance, necessary if you want to have a complete picture of which software is used, for instance, for a vulnerability analysis, or if there is a question of license schemes of different software elements, then you use the SBOM. But also, very simply speaking, when it comes to traceability, defects across variants, all that is subject to using a very good support for SBOM. That's the topic next week. And from here onwards, I would also already point you to the Vector Forum 25, which is in similar setup. And we will look next year more on how can we bridge these two ecosystems. On the one side, the critical systems, like what we just heard, safety, critical systems in medical, in transport, in automotive, with the lessons learned from continuous IT, fast development with techniques like DevOps, DevSecOps, etc. There's still a lot to learn, but also still the need to keep some best practice, like what we heard today from Lubomir and from Michael about functional safety. You can already register. It's similar to this year, just that it is about 25. And I want also to come back also on our quiz, which is accessible from this link, which you find here. And from here onwards, I thank you very much for joining. I thank again to Lubomir Jovanov and to Michael Rölleke for this very good presentations, for the Q&A. I thank all of you for joining. For those who join remotely, stay tuned. You will also have some connect, which you see here with www.vector.com consulting. Thank you and good success with your AI projects.
Yep. Thank you.
Thank you.